Hello, this is a video about the Qibec 1-bit 1 instruction transistor CPU that you can see here. Today we'll talk about the multiplexer plug-in module, which looks like this. It's one of the modules implementing the digital logic of the CPU. In total there are 4 of these modules inside the CPU, and together they form the 16-bit multiplexer, choosing between a next program address and an optional branch address. And how this works is detailed in another video, is not discussed here. Instead, this video will show what a multiplexer is, how it works, how to construct it out of gates, and finally we'll look at the behavior of the multiplexer on the breadboard. So, inside the CPU there's a 16-bit multiplexer. But let's for now consider 1-bit multiplexer, because a 16-bit multiplexer can simply be made out of 16 1-bit multiplexers in parallel. A multiplexer is basically a switch, choosing between inputs A and B and connecting either A or B to an output Y. Now, instead of an actual mechanical switch going up and down, there's a separate input named select. Let's assume that if that input is 0 or false, the switch is in the uppermost position, so input A is connected to output Y. And of course, if select is 1, the switch is in the downwards position, connecting input B to output Y. Now, when making a multiplexer out of gates, a 1-bit multiplexer, let's remember that if you have this AND gate, you connect some value to one input and connect a fixed 0 or false to another input, the output is always 0 or false. Furthermore, if you have this AND gate, connect the same value to one of the inputs and a fixed 1 to the other input, output value is always X. With this in mind, the 1-bit multiplexer can be made like this. 2 AND gates, one connected to input A, another connected to input B. You have a select input, which is connected to the other inputs of the AND gates in this way, with an inverter between the 2 inputs. The outputs of the AND gates go into an OR gate, which forms the output Y. Now, if select is 0, the output of this AND gate is always 0. If this is 0, after the inverter the value is 1, so the output of this AND gate is always A. The OR function of A and 0 is A. So if select is 0, the output of the multiplexer is A. So 0 selects input A. Likewise, if select is 1, the output of this AND gate will be B. If this is 1, after the inverter the value will be 0, so the output of this AND gate will always be 0. Now the OR function of B and 0 or false is B. So a select value of 1 will choose input B to be the output of the multiplexer. That's basically how this works. So it's not much. There's not much to it. This is the simplest gate in the whole CPU. Or the simplest module in the whole CPU. It's a combinational module, which means it doesn't have any memory. It's very simple, as you can see. There's only 3 gates in each bit, so there's not much to say about it. This, if you look at the, this is a 5-bit multiplexer, as the text says. So this was a bit of a design error. It's could be a 4-bit multiplexer, because in total we need 16 bits, and you would need 4 of these boards and then throw away 4 bits, or you can simply make modules that implement a 4-bit multiplexer and put 4 of these in the CPU and also end up with 16 bits and not throw away any bits. So this will probably change this board in a next version. If you look at the inputs, there's VCC and ground obviously. There's one select input. So the select input that you just saw on the whiteboard is shared among all the bits. In other words, this board basically implements 5 switches, and all the switches change position from up to down and vice versa when this single select changes. For each bit, I'm not sure if you can see that. Yeah, for each bit there's an input A, 0A until 4A. For each bit there's another input B, 0B until 4B, and then for each bit there's an output, that is 0Y until 4Y, and 2 ground pins. So here you can see there's only one inverter used. So instead of implementing an inverter for each multiplexer, as we saw on the whiteboard, this inverter is taken out and shared among all the bits. So, to see how this works, you can stick it in the breadboard like this. It's not very spectacular. So, in the previous video I used LEDs and push buttons on the breadboard itself. So instead I connected wires to that. As you can see, I'll use the CPU as a table now, and I remember that I made a box that does exactly this. It has push buttons and LEDs, so you can see what's going on. You can see 3 signals, A, B and select. A and B are the inputs to the 1-bit multiplexer. I can apply a signal from the function generator to it. And, let's invert these signals or get them out of phase so we can see the difference. Now, using this switch you can select between 0 and 1. The LED off is 0, LED on is 1. So in the normal position the select input is 0, and that would select input A to be the output of the multiplexer. Output of the multiplexer can be made, can be visualized like this. So now we have the select input, we have input B, input A, and the output of the multiplexer. And as you can see, since the select input is 0, input A is selected. So the output Q follows input A, right? The middle LED, the LED for Q follows the LED of A. Now if you toggle the select input from 0 to 1, you can see that the output Q will start following input B. Release it again, output Q follows input A, right? So that's basically how it works. And if you implement this 16 times in parallel, you can choose between 2 16-bit values instead of 2 1-bit values. So that's all basically. I hope you liked it. Let me know what you think. Please watch the other videos if you're interested. For more information, see the Qibec site. That's qibec.org. It's also listed in the video description. Now, thank you very much. Have a nice day and goodbye.